Hello and welcome back to another video, and in this video we are going to talk about the non-consecutive repetition operator. So let's begin. So in our previous video we talked about the go-to repetition, and in go-to repetition you have to just watch the previous video because the pattern was a bit complicated. So the question for this non-consecutive repetition is going to be same, but it will have a slight difference. So first, how do we denote the non-consecutive repetition? So it is denoted inside a square bracket, just like the go-to repetition, but instead of using a symbol for the implication operator, you will use an equals to. So let's begin with the question. So our question says that if A is true, then on the then B should be true at least two times or twice and at most 10 times. So it's pretty much same as our previous question. So it should be true for at least two times and at most 10 times, and the reps or the repetitions of B are not required to be consecutive. So the repetitions are not required to be consecutive. So we will keep looking and keep checking for the pattern until and unless we have detected B for at least two times or at most 10 times. And how do we determine at most 10 times? Because then after that, at any clock cycle, so at any clock cycle when this particular pattern is detected, C should be true. So the only difference here is that in our previous video our requirement was something like that. If A is detected, then on any of the clock cycle, let's say B is not true for this clock cycle, then B is true, and then again B is not true, B is not true, and then B is true. So when last B is detected, so C should be true right on the next clock cycle. So it should be something like that B last true B is detected, then C should be true. It can be like that B is not true here, then C is true. So it can be like that. The condition fails. But here in this particular example, it even relaxes that in this example, if this is the sequence we detect, then the assertion pass. So when the consecutive repetitions, uh, non-consecutive repetitions of B are detected, C is not required to be detected right after the last true B is detected. It could be true any clock cycles. It does not matter how many times B is deserted. It could be true any clock cycles after that. So let's begin writing that sequence, but first without the non-consecutive repetition to help understand it better. So let's begin with the sequence, and the sequence should be something like this. First I will write N, which basically means not, So it's not a non-consecutive repetition. And S, which denotes sequence. So let's begin with our sequence. So A should be true. Then after that, we will do the same thing that we did on our previous video, in our previous video, with the go to repetition example. So I will write two brackets, and inside this, the first thing says that P can't be true for at least 0 times and at most infinite number of times. Then right after that, B is true. B should be true. And we want this pattern to be repeated for at least 2 times and at most 10 times. So right after this, what we did in our previous video, we just write that C should be true. But here it is not true that C could be true at any clock cycles later when this pattern is detected. But remember, there is also an upper bound, and the upper bound is the 10 times. So if this pattern is detected and if C is true after the 11th true B, then the assertion fails. So right after we detect the 11th true B, the assertion automatically fails. So C should be true within 10 numbers of asserted B's. So we have to change this, and right after this, since we are relaxing it, we will repeat the same thing, that B cannot be true for at least 0 times and at most infinite number of times, and then C should be true. So this concludes our entire pattern for this particular question, and yeah, this is very troublesome. So now we will write the same thing, but this time using the non-consecutive repetition. So we just have to write A is true, then on the next clock edge we will write something like this B, and inside the square bracket we will use the symbol equals to, which indicates that it's a consecutive, non-consecutive repetition, and it is required to be repeated for at least 2 times. So we will write 2 and at most 10 times. So upper bound is 10. So 10 and then C. So it is this simple. If you write the pattern using the consecutive repetition. So let's write the property for this sequence. It should be non-constrap, and we want this particular sequence to be sampled at every passage of clock. Right after that, let's assert the property. Before that, let's label the assertion. So assert the property, and if it fails, it will throw an error, and it's a concurrent assertion. It will keep getting checked during the entire simulation run. So this concludes our another type of operator used inside assertion, and system verilog assertion is a different type of language itself inside our language. So the only difference between this and the go to repetition, which is denoted like this, so the only difference between this and this is that the signal you write, the signal or sequence you write right after the go to repetition, sorry, I mean the non consecutive repetition, is not required to be true right on the next clock cycle. In simple words, C is not required to be true right after the last true B is detected. So I hope you find this video useful and stay tuned for more. Thank you so much.